Imagine a bridge that soars 625 meters above the clouds, where the laws of physics seem to break. Today, we'll reveal the secrets of Huajing, the world's highest bridge, and how Chinese engineers conquered the most rugged terrain to build this legendary structure with cables weighing millions. In this video, you'll discover the journey of challenge and innovation behind this achievement that changed the landscape of global trade. Don't miss this incredible experience. If you're a fan of engineering marvels, hit the like button and subscribe to the channel to join us on our upcoming explorations. Let's begin. The journey of this record-breaking bridge begins in one of the most rugged regions in all of China, Guizhou Province, known for its harsh and unforgiving terrain. Over 92% of its area consists of towering mountains and deep plateaus, intersected by 8 major rivers and countless tributaries that form deep valleys, making trade and transportation a constant challenge for the inhabitants. Thus, to pave the Liuji-Anlong Expressway connecting Liupans to Anlong County, the route had to traverse the perilous fork of the Berin River within the Huajing Gorge. From this necessity, the Huajing Bridge was born, a structure whose significance transcends that of a mere bridge. During the surveying phase, engineers faced 2 options with similar costs: constructing a more streamlined access road with the bridge near the mountain's summit, or building the bridge at a lower elevation, traversing a series of steep inclines and long tunnels. Ultimately, they chose to take on the challenge at an altitude of approximately 762 meters. However, the V-shaped gorge created a distance of over 1,400 meters between the 2 escarpment's edges. Faced with this immense span, all other bridge designs fell short. The world's longest steel-framed bridge could not cross this distance, nor could the longest arch bridges, and even the largest cable-stayed bridges, which lacked the capacity to traverse such a vast expanse. Only the Superspan suspension bridge was able to meet these stringent engineering requirements. But how do you build such a colossal bridge in such unforgiving terrain? Theoretically, it requires 3 steps, starting with the construction of the 2 towers, then pulling and securing the 2 main cables, and finally, suspending the bridge deck using suspension cables. However, the reality is far more complex. The Huajing Bridge rises 625 meters above the river and spans 1,420 meters across the gorge. When its tower structures are included, the bridge's height approaches that of the tallest man-made structure in the world. With these astronomical figures, it's clear that the Huajing Bridge isn't just massive on paper. Its construction far exceeds the standards of typical infrastructure projects. Beyond the challenges of the terrain, the structure's foundations presented another dilemma. The bridge towers had to be laid deep within weathered rock layers riddled with cracks and groundwater, where the slightest mistake could lead to catastrophic accidents. Therefore, engineers employed a special piling system, driving 24 massive concrete piles deep into the earth, reinforced with earthquake-resistant steel, to ensure the tower's stability for decades to come. After overcoming the obstacles of the foundations, the next step was to construct the bridge's 2 main pillars. The 2 main towers, one 262 meters tall and the other 205 meters, which serve as anchor points for the entire cable stay system. These towers were built directly into the mountainside, hundreds of meters above the gorge, alongside 2 massive cables, each weighing over 9 million kilograms. These towers support the bridge like two giant pillars holding a silken ribbon across the sky. Because stability is paramount, the entire structure is reinforced with high-strength steel capable of withstanding strong winds, vibrations, and even earthquakes throughout its design life. To demonstrate the tower's true strength, the cable anchoring system at both ends of the bridge must be robust enough to secure the entire structure in place. The Huajing Bridge's anchors act as giant counterweights, firmly anchoring the two main cables within the mountainside. On the Jimfang side, the gravity-based anchorage rests firmly on the mountainside, with a concrete volume of 164,000 cubic meters, forming a highly stable, resistant mass. In contrast, the anchorage on the Guanling side is designed as an anchor within a tunnel. Instead of placing a massive concrete block on the surface, engineers carved deep into the mountain and anchored the anchorage system directly into the natural rock, transferring the entire cable tension to the mountain's core. The reason for this choice is clear. Behind the tower on the Guanling side lies a steep mountain, and the available flat space is extremely limited. Using the mountain itself as a natural anchorage was the ideal solution, saving space while increasing the stability of the entire structural system. After the anchorage blocks were completed, the next step was installing the catwalk, a temporary suspended walkway between the two towers, while workers constructed the entire cable system. To pull the first guide cable through the thousands of meters deep trench, engineers used drones, making the cable routing process safer and more precise. Once the string was successfully pulled, the walkway was formed, laying the foundation for the most critical phase, the construction of the bridge's two massive main cables. The next step, and arguably the most important phase of the entire project, was the construction of the two main cables, the bridge's supporting backbone. Each main cable consists of tens of thousands of high-strength steel wires woven together with absolute precision to form a structure capable of carrying tens of thousands of tons. On this suspended walkway, workers installed each of the cable bundles, each consisting of 91 high-strength steel wires with a diameter of 5.7 millimeters. These bundles were pulled back and forth between two anchor points under precise GPS tracking to maintain a margin of error of less than 2 millimeters. In high winds and at an altitude of thousands of meters, controlling every movement of each bundle was of paramount importance. Once all 217 bundles were installed, a cable crimping machine compressed and bound them into a circular cable using a specialized crimping process. The cable was then coated with multiple protective layers to resist corrosion, weathering, and vibrations for decades to come. Only with these two massive cables complete could the bridge truly move to the next stage, suspending its deck in mid-air. Once the two main cables were in place, the bridge moved to its crucial phase, suspending the deck. Engineers first installed the vertical cable system, each connected to the main cable using specialized clamps capable of withstanding thousands of tons of force. These cables transfer the load from the bridge deck to the main cables, then distribute it to the two anchor points. Next, the entire bridge girder, composed of 93 steel segments, was lifted one by one, starting from the center of the bridge and gradually extending outwards to the sides. Each segment, weighing hundreds of tons, was hoisted using a pulley system suspended more than 610 meters above the water's surface and connected to the suspension cables via specialized load-bearing couplings. During the installation process, engineers had to constantly adjust the cable slack, tighten the cables, and fine-tune the position of each segment to ensure the entire deck remained aligned without tilting or twisting in the wind. Once all 93 segments were in place and connected into a unified structure, the deck system was constructed over them, transforming the suspended steel frame into a fully functional highway. After construction was completed, the next step was to assess the bridge's actual strength. In a load test conducted in August 2025, 96 heavy trucks with a combined weight of 3,700 tons were used to evaluate the bridge's load-bearing capacity and dynamic performance. More than 400 sensors recorded data on deformation, stress, and vibration, ensuring the bridge met the highest safety standards. This test not only confirmed its absolute safety, but also demonstrated breakthroughs in real-time structural health monitoring. Throughout the construction of the world's highest bridge, the construction team constantly faced extremely harsh challenges from nature and terrain. The Huajing Gorge is known for its strong winds. In favorable seasons, wind speeds can reach level 14 on the Beaufort scale, while construction work must be halted whenever winds reach level 6 or higher to ensure worker safety. When transporting the steel girders to the installation site, the anchoring cables sometimes became entangled, requiring workers to manually straighten them and maintain the line's balance to minimize the risk of warping. Work began at 6 a.m. and often didn't finish until after dark. Besides the wind and rugged terrain, the sheer volume of construction materials presented a significant challenge. The Huajing Bridge required a total of 439,000 cubic meters of concrete, equivalent to 176 full-size, Olympic-sized swimming pools. To reduce costs and protect the environment, engineers reused the waste rock generated during construction. This rock was ground into a high-performance green mineral powder and used as a supplementary material, replacing 20% of the cement in each cubic meter of concrete. This approach not only saved on cement and reduced costs, but also fully utilized the waste rock, helping to minimize pollution and conserve natural resources. Thanks to these measures, the construction team not only overcame the natural and geographical challenges, but also completed the project in a sustainable and efficient manner. After all the effort invested in conquering mountains and cliffs, the bridge now opens up entirely new horizons for the region. Previously, the journey from the bridge area to Guangzhou City took at least 3 hours. Now, it takes only an hour and a half, saving almost half the time. The speed of transportation not only makes life more convenient for local residents, but also benefits thousands of others in the region. As a transportation project combined with tourism, the Huajing Bridge was designed from the planning stage to ensure both structural safety and an exceptional visitor experience. With its expansive views, ideal height, and breathtaking scenery, the bridge's sides are equipped with safety rails and a specialized pavement coating that not only stabilizes the surface, but also supports high-altitude adventure sports. At the heart of the steel girder lies a pedestrian walkway that would have been merely a maintenance access point were it not for the project's tourism-focused vision. Its impact extends far beyond what is visible. By connecting to the highway, the bridge not only shortens travel time, but also opens up regional trade routes between China and Southeast Asia, attracting investment, creating jobs, and improving education and healthcare, thus propelling the entire region toward a prosperous future. In conclusion, the Huajing Bridge remains more than just an architectural marvel of steel and concrete. It is living proof that human will knows no bounds in the face of nature's might. Today, this structure not only connects the two banks of the deep gorge, but also builds a bridge to a promising economic future for millions of people. If you enjoyed this journey into the depths of Chinese engineering, please support